Hello, this is a Regent review for Unit 2, Quadratic Functions and Factoring. Each section will cover a different standard that the Regent exam could test you on pertaining to Unit 2. So first, it's graphing quadratic functions, and it says a parabola has a directrix of y equals 3 and a vertex at 2, 1. Which ordered pair is the focus of the parabola? So I think it's best if you draw it out to try to visualize it. So you could do a quick rough sketch. The directrix is at 3. Directrix is just a line. Vertex is at 2, 1. Now, your vertex is, either your minimum or your maximum point on a parabola, and a parabola cannot cross the directrix. So, we know that this is going to be concave down. And any point on that parabola is equidistant from said point to the directrix to that same distance of that point to the focus. So the easiest thing you could do is count, right? Vertex is 2, 1. So this distance here is 2. So you're just going to go 2 down. So it goes to 0, then to -1. Your focus would be the same x value of 2, and then 2 y values down. So 1 minus 2 is -1. So 2, -1 would be your focus. Something else that you could do, you could use your formula, the conic form of a parabola. Y minus k for p times y minus k equals x minus h squared. And then you should know the other formulas as well. Your vertex is simply hk. Your focus is hk plus p. Your directrix is y equals k minus p. So those are the formulas that you really should memorize. There is another way to do it using the locus definition of the parabola, but you have to take into account displacement, and some of you haven't taken physics yet, so it could be, incredibly confusing for students that don't understand displacement. So those are the formulas. Let's just minimize that so it doesn't take up so much room. And we don't have the equation of our parabola, but we do have the vertex, right? The vertex is 2, 1. Let's see if we can use this way here. Okay. Your directrix, you could solve for P. Your directrix y equals k minus p, y equals 3. So 3 equals k minus p, right? your vertex is of the form hk, so your k is 1. You're going to add 1 on both sides. You could get that k equals, whoops, k is 1. You could add p to both sides, subtract 3, and you get that p equals -2. So, since you have your p, you could plug that in to find your focus now. The h is just 2. K we said was 1 plus -2, so your p. So you have 2, -1. So that's just another way of doing this. The other way that you could have done this was using your locus definition of a parabola, but again, it takes a lot of algebraic manipulation, and for like a little multiple choice question, I don't know if it's worth the time. Okay, which equation represents a parabola with a focus of 0, 4 and a directrix of y equals 2? So y equals 2. Is the directrix, focus is 0, 4. You know that any point on a parabola is equidistant from the focus to that point, as well as from that point to the directrix. So it has to be directly in the middle. So the vertex will be 0, 3. And we know it has to be concave up, because you could either think of it like a ball in a cup, where the focus looks like it's contained in the parabola, or you just know that it can't go through the directrix. So now we have the vertex. So yeah, again, there's two ways of doing this. You could use the formula, or you could use the locus definition of a parabola, right? If you know how to use the locus definition of a parabola, what you could do, pick an arbitrary point, right? This is an easy distance to measure, right? Because it's just that height of y minus 2. So then this would be y minus 2. And that has to be the same distance as from here to here. And then you would use your distance formula, set them equal to each other, and then solve. But it would be a lot of algebraic manipulations. So that's how you would do the locus definition of parabola. What I recommend doing, which is a lot less work, using the formulas. So you have, rather than rewriting it, I could copy and paste. Okay. So you have HK, right? I'll use the same color. The vertex is your HK. So the vertex is 0, 3. If you want to start plugging it in, you can. So 4p, we don't know RP. RP, by the way, is that displacement, or the distance. So since this is concave up, it's going to be positive, and it's just that 1. It's going to be 1. But again, you could just solve for it as well. So let's show how to solve for it. Y minus 3, 3 is your k. X minus 0 is your 0 is your h. So we're given either the focus or the directrix, whatever you want to use to solve. Let's use the directrix. You know, we did the directrix in the last one. Let's do the focus. So the focus is 0, 4. It has k plus p, right? So k plus p equals, we said the focus, that y value would be 4. You could plug in what k is in the vertex, which is 3. So 3 plus p equals 4. Subtract 3, and you get p equals 1, just like we said from looking at it. All right? So p equals 1. So if we want to simplify that, we could input 1 for p. So 4 times 1 is just 4, times y minus 3 equals x squared. Multiply out the, it's in terms of y. It's solved for y. So what you could do, divide by 4 on both sides, add 3 on both sides. So I'm assuming the question looked like that, but the PDF probably got messed up there. Okay. For number 3, parabola that has a vertex of 2, 1, and a focus of 2, negative 3, has an equation of, okay, so you don't really need to draw the directrix, but you can if you want. You know, it's like a bowl in a cup, so it's going to be concave down. Your p is going to be negative. Your p is actually going to be 1, 2, 3, 4, so negative 4. But since this is a rough sketch, it's very easy to make a mistake that way. So, 1 minus negative 3 would be 4. So, yeah, negative 4 since it's concave down. But let's use our formulas. Okay. I'm going to pretend like I don't know that it's going to be negative 4. Because what if I made a mistake, right? Y minus, your vertex is of the form hk, right? So y minus, your h is 2. Your k, well, your k is 2. Your k is 1. And your h is 2. So we're going to have to solve for p. That's your focus, k plus p equals negative 3. We said our k was 1. Subtract 1 on both sides, and you get p equals negative 4. So 4 times negative 4 times y minus 1 equals x minus 2 squared. 4 times negative 4 is negative 16. Y minus 1 is x minus 2 squared. Divided by negative 16. Add 1 on both sides. And you get y equals negative 1 over 16, x minus 2 squared plus 1. Okay. Again, you could use the locus definition of a parabola, but then you would have to understand that your displacement is going to make it negative x. That horizontal distance, it would be negative x, and then depending on if you're adding or subtracting that distance. So I wouldn't, it could be very confusing. So like I said, I recommend using the formulas. Okay, now for factoring, it looks confusing. The Algebra 2 Regent kind of expects that you are an expert at factoring because you were assessed and passed Algebra 1. But this is a trinomial, so it's just like a regular factoring problem. If you want to turn it into a quadratic, you can, right? And rather than having, x, what would you have inside the square? You have x squared, right? Because it's x squared is x to the fourth. So, looks very similar to a regular factoring problem now, right? So, you have a negative sign on the product term, so that means different signs. Rather than having x as you normally would, you have x squared, right? And then, what factors of 12 would subtract 2, 4? 6 and 2. So you have negative 6 and positive 2 because you want it to sum or to subtract to negative 4. The next thing to check is if you could factor this any further. We have a perfect square here and we have a difference, but we don't have another perfect square. So you can't do difference of perfect squares. This isn't even a difference, and it's also not two perfect squares. So that's factored completely. That's your answer. Okay. Over the set of integers completely factored. Oh, we have another trinomial. So we have a plus sign, so that means same signs. And then we look to the sum term, and both of the signs are going to be negative. So we already know that this is going to be x squared minus x squared minus. And then what factors of 4 would sum to 5? That would be 4 and 1. Now, is this factored completely? No. You have two perfect squares. You have 4 perfect squares and differences. Alright? So you have two differences perfect square problems. So difference of perfect squares lead to the conjugates. So there's a negative, so it's different signs. And then square root of x squared, x. Square root of 4, 2. Same goes for the other difference of perfect square. Square root of x squared, x. Square root of 1, 1. Now that's factored completely. Okay. Again, the Algebra 2 Regent with the factoring problems, they're infamous for making easy factoring problems look more complicated than they are. This is just a trinomial. So you have a plus sign on the sum term. So that means it's going to be same signs. Both of those signs are going to be positive. So both of them are positive. What's in the place of what normally would be x? X plus 2. And then what factors of 3 would add to 4? 3 and 1. So is anything happening on the outside of that parenthesis of the x plus 2? Is there any multiplication that we have to distribute? No. So you could drop the parentheses. X plus 2 plus 3 is just x plus 5. X plus 2 plus 1 is x plus 3. So we're looking for x plus 5 and x plus 3. That would be answer number 2. All just factoring trinomials. Let's hope we have a factoring variable. Oh, yeah, we do. When you have a even number of terms, right, what kind of factoring would we have to do? We would have to do factoring by grouping. So group the pairs, and we can't magically just get multiplication, right? Because it was subtraction. So plus a negative is the same as saying subtracting. So you have to remember to put that plus sign. Now, what's the greatest common factor in this first group? 2 goes into 2 and 6, and then d to the third goes into d to the third and d to the fourth. So you would be left with d plus 3. What's the greatest common factor in this second group? I know I'm going to factor out the negative because I want it to be of the form d plus 3. And what I'm going to do, I'm sure that 18 probably goes into both because it's probably going to be the form d plus 3. But what I could do, I'm going to go to math, go to num, go to GCD, which stands for greatest common divisor. Another way of saying GCF, which is greatest common factor. And I could put 18, comma, 54. It looks like the greatest common factor is 18. This is what it looked like in my calculator. So I could pull out that negative 18, and it looks like there's a d. So you would be left with d plus 54 divided by 18. Let's just make sure that's 3. And it is. Now what's the greatest common factor that's in these two terms? What's the thing that you see that's in common with those two terms? D plus 3. Factor it out. So, and when you're factoring out, if that's confusing you, just picture it without this. So the part that I'm highlighting, picture it without that. Right? When you factor it out, you're basically dividing it out, but you're including it as a product so that it's an equivalent expression. And then it's everything that's left. And that's exactly where we got that. Okay. So now the greatest common factor here. It's definitely going to be 2d. So I'm going to factor out 2d. And we're left with d squared minus 9. Now we have a difference of perfect squares. So it's different signs because the conjugates. Square root of d squared is d. Square root of 9, 3. Now that is factored completely. If you notice, there's 2d plus 3's, so that's the same as saying d plus 3 squared. So we have 2d, d plus 3 squared, d minus 3. Answer choice 3. Okay, we're going to do the same thing here. Factoring by grouping, there's an even number of terms. Group them, make sure it's separated by addition, factor out the greatest common factor, factor out that greatest common factor, factor out the greatest common factor in that, there's a difference of perfect squares, so it's different signs. Square root of x squared is x, square root of 9 is 3. And now it actually wants us to use the zero product law to actually find the zeros. Interestingly enough, I feel like what confuses students the most is the easiest one. So let's skip that one for a second. Let's do x plus 3. You set it equal to 0. you solve, and you find that x equals -3. Same thing goes for this one. What is this going to be if it's negative? It's going to be +3. This one's negative as well, so it's going to be +4. But this one, let's do our own first step, setting it equal to 0. The next step would be solve for x. Isn't it already solved for x? So if you ever have x alone, or you have, let's say, 3x or 9x, a number isn't going to change that, right? 9 times 0 is still 0. So if you ever have x by itself and it's not in parentheses and centered at a certain point, it's going to just be equal to 0. And then conventionally we go in least to greatest order, and it looks like they're using plus or minus, so I'll show the conventional way, and then we see -3 and positive, so it's plus or minus 3. So 0 plus or minus 3, 4. Your answer is 1. Okay. Last question. Algebraically determine the solution set for the system of equations below. What I recommend doing is, it says algebraically. Okay. For a lot of these questions, usually these kind of systems of equation questions are on multiple choice. And rather than algebraically doing it, I would put this in my calculator as y1, y2, graph it. Just probably do zoom fit to show the point of intersection. I might have to zoom out. And then I would do second, trace, intersect, enter, 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 and it would give me the points of intersection. And that's a good way to check your work, but it wants us to algebraically solve. We could just do substitution since it's already solved for y. So I'm just going to substitute in that value of y here. So 11 minus 2x equals 2x squared minus 7x plus 4. We have a quadratic. We know we want that to equal to 0. So we could add 2x to both sides, subtract 11 to both sides. So negative 7x plus 2x, negative 5x. 4 minus 11, negative 7. You could use quadratic formula, or you could check to see if you could factor. But let's use quadratic formula. I always recommend listing out your a, your b, and your c. A is just 2, b is negative 5, c is negative 7. Notice we're not including the variable or the exponent. It's just coefficients and constants. We're going to plug into this formula, quadratic formula, which is provided on the Regent reference sheet. Notice I'm including parentheses. If I did not include parentheses here, I would be wrong, because if you don't include parentheses, rather than doing negative 5 times negative 5, you would be doing 5 times 5 and then multiplying that by a negative. Okay, negative times negative 5 is positive 5. Over 4. I'm going to put the radicand in my calculator. (81). Square root of 81 is 9. In my calculator, I'm going to do 5 minus 9 divided by 4. Make sure you put the numerator in parentheses. I'm going to do the same thing, but with 5 plus 9 now, because it was plus or minus. You get 3.5. So x equals -1 and 3.5. That's your 2 points of intersection. If you want to picture this, that would look like a quadratic and a linear, and you have 2 points of intersection. What could have been, it could have never intersected it, right? Or it could have intersected it at one point. So you could have up to 2 solutions, and you could always have, 0 solutions. But that is the Unit 2 Regent review. Hopefully this helped. Thank you.